Okay. So P1, graphs and models. So now we are into our review. We are starting with our review chapter. There's certain sections will move faster than others. This one should go pretty quickly, and we'll work from there. So P1 is on graphing. Okay. So how do we graph a line? Or graph an equation? You can graph it one of three ways. You can do it using a calculator. Okay? You can either do it with Desmos or the graphing calculators. Okay? So that is doing the graph graphically. Or you can sketch it by hand. Okay? So you can use a calculator to do that. You can find it by just using an XY table, which that is what we call numerically. That's where you're literally plugging and chugging to find all your missing info that you need. And then the last way is if it's a linear equation or based off of a parent function, you can use the slope, y-intercept, or parent function. So this should also say or parent function to do it analytically based off of a formula.
What's that after the y-intercept?
Y equals mx plus b.
Okay. So the three ways we look at graphs: graphically, numerically, and analytically. Graphically, numerically, and analytically.
What's the y equals 7 plus 2x?
Oh, that's just there. That means nothing. Okay. Are we good? All right. So if we have y equals 7 plus 2x, and I want to go through this and graph it, the first thing we have to decide is, okay, do I want to plug it into a graphing utility? So do I want to use like a graphing calculator or Desmos to graph this? I would hope you wouldn't need that for a linear equation. Okay? If you choose to do it that way, that's fine. All right? So you have that. The second way, and probably the most logical way to do it, is to do an XY table. Okay? So if I make an XY table, does anyone remember from Algebra 2, what's the key number of points for
1, 2, 1,
3?
0, 1, 2.
Okay? I really like it if you give me 5, 2 positive, 2 negative, and 0. But at minimum, you have to have 3 points. A positive, a negative, and 0. Okay? So, since it's linear, we'll just do a quick 5-point table. So, negative 2, I plug that in. I get 7 plus 2 times negative 2. So that's 7 plus negative 4, or 3. Yes?
Yeah.
I plug in negative 1. 7 plus negative 2, or 5. 0. 7 plus 2 times 0 is 7 plus 0, or 7. It goes up by 2, if you notice this. 7 plus 2 is 9. 7 plus 4 is 11. Okay? That's the second way. And then you could plot these 4 and 5 points and do it that way. Now, just to remember, so if I was going to plot this, it's really -2, 3. So I'll go -2 and up 3. All right? You can graph it that way. What I'm going to show you is the analytical way, using the formula. Okay? So 7 plus 2x. If I want to graph this using the formula, y equals mx plus b.
Should we make that one graph?
It's up to you. If you want to graph it, you can. If not, don't worry about it. Okay? So, is my equation 7 plus 2x in y equals mx plus b form?
No, we got switch.
We got to switch them. But it's addition, so can I switch them around and it's not a problem?
Yes.
This is the same thing as saying 2x plus 7. Okay? So, when we're using y equals mx plus b, what does the m stand for? Slope. What does the b stand for? Y-intercept. So when I'm graphing using y equals mx plus b, where do you start your graph? At the y-intercept. So I count up to 7. 1, 2, 3, 4, 5, 6, 7. Okay? And I put a dot there. Then my slope is 2. So what do I do with that? Up 2 over 1. So I treat my slope as a fraction. 2 over 1. And I do rise over run. So you go up 2 over 1. Up 2 over 1. Yep. So can I also go down 2 left 1? Of course. Yeah, it means the same thing. As long as your slope ends up being 2, you can go about it however you want. So, now, if I'm you, if I find my XY table, that's what I go with. And I just plot those points. But I just wanted to show you that there is 3 ways to solve every graph. Okay? So that's analytically, that's numerically, and then if you use graphing technology, that would be graphically. Yeah.
Why would you use the table instead of the way
Just
you
doing-
used it?
That way we just did only works for lines or basic parent functions. This works all the time. So XY table is good for more complicated functions like x to the 4th plus 4x squared plus 2x plus 2. Times like that, you don't know what all those additional x's are doing to the graph. So you have to make a table. And usually, if the more complicated, the more plus and minus signs, the more points you're going to need. And no, I'm not ever going to ask you to graph that whole long thing by hand, so don't worry about that. You'll either use a graphing utility, Desmos, a graphing calculator, or whatever, but you're not going to have to do it by hand. Okay? All right. Questions on that one before we move on? Are we good? All right, so that was a line. Okay? Try this one. Pick one of the 3 methods and graph it. So you can either plug it into a graphing utility, do an XY table, or slope intercept.
So if we do an expert table, we do a graph with it.
Yes. Either way, you should graph it. I just saved the graph, so we only have to graph it one time.
What's the little?
I just moved
Oh,
it.
you're like helping us.
I was helping you out. I missed the step when I was erasing. Because these are last year's notes. I just didn't get everything erased. Just put -3x plus 7. Yeah, that'd be a graph. Then we're gonna pose.
do X, Y. Yeah.
Seven out of 10.
I
I like to show them the second one. The first one. So thank you.
I said nice, so I know. So I would say practice. What? Fine. Just trying to one here. Oh, this one.
It's called systems diffusion. Nice.
Holy. Whoa. Okay. How many of you did?
Numerically, I mean,
How-
analytically, in the long run.
Okay. Numerically. How many of you did XY table? Okay. How many of you did slope intercepts?
Oh,
How many of you did graphically on the?
thanks.
Yeah.
Okay. So XY table. Well, what do I got to do first before I can do any of that? Put it in the slope intercept form. So I got to move 3x over. So I got y equals negative 3x plus 7. Now, can you leave that this way? 7 minus 3x? Yeah, it doesn't really matter. If you're doing slope intercept form, you need to switch it. But if you're doing a table, leave it. It's not that big of a deal. Okay? You plug in negative 2, you get 13. Plug in 0, you get 7. Plug in 2, you get 1. Is that right?
Yep.
Okay. Go up to 7. Put a dot. Down 3 over 1. Down 3 over 1. And connect. Okay? Questions there? All right. Now,
Just another example.
yep. So, pretty easy to graph lines. Not so easy to graph something that's not linear. So you got y equals x squared minus 2. So this comes back to when I mentioned parent functions that we talked about in Algebra 2. So you have to look and see what is the largest power. Largest power is 2. It's the only power. So then we have to remember, okay, what does a graph that's y equals x squared look like?
It's a U.
It's a smile, right? Okay? Remember we talked about that. A positive x squared is a smile. Negative x squared is a frown. Okay? Also called a parabola. Right? So, now the question is, so a normal parabola is centered at 0, 0.
Oh.
And it looks like this. It's not perfect, but it's close enough. But now, what does that minus 2 do?
Gotta take it down to.
It moves the whole graph down 2 units.
Then what's the? Do we just guess on the R's?
Yeah, it doesn't have to be perfect. Now, could you make an XY table and do it that way as well? Yeah. But if you know the parent functions and you know what type of shift that is, just do it that way. Okay? So, yesterday when we talked about trig functions and how they have 4 different keys: amplitude, the period, phase shift, and vertical shift. Well, when you're graphing quadratics and any other conics, they also have an amplitude, how fast it goes up or how wide it goes. They have a phase shift, if there's parentheses squared, and then a vertical shift, plus or minus at the end. Okay? So when you're doing quadratics, they follow this formula. Okay? A is your amplitude. That tells you how fast. It's like the slope. It's not the exact same thing, but it's similar. Okay? C is your phase shift, but it has to be inside the parentheses. So that moves your graph to the right, C units, just like it did with trig. And then D at the end moves up or down. If it's plus, it's up. If it's minus, it's down. So that's no different than what we did yesterday, except for it's a quadratic instead of trig. And obviously with a quadratic, there is no period. So, okay?
How do you work these calculators?
Now, those of you that did do it graphically and used the calculator, that's fine, but you better understand how to show your work and do the work manually as well, because when it comes to an exam, if you just copy down the graph off your calculator and did on calculator, you're not going to get a whole lot. Because, you know how to push buttons on a calculator, but you understand how to actually do the problem. All right.
How do you zoom out on these calculators?
Zoom. You hit the zoom button,
Yeah, I tried.
and then zoom out.
Try it.
Okay.
Not working.
Now,
Okay.
we'll come back to, we'll have a day on calculators. I just want to get through this stuff for right now. Okay. So, what if I have a problem like this?
You skip.
So, yes.
Yeah.
The first one, real easy to do using a formula. The second one, if you know the parent function, not too terrible to do by the formula. What about a problem like this?
You just skip it and take the L.
Okay? Skipping it and taking the L is not an option.
Then you drop the class.
Dropping the class is not an option.
Try.
Shoot, it's
Right.
Thursday, not Wednesday.
Crying's not an option. Well, it's an option, but it's not getting you anywhere.
Ask Lily about crying to Johnson.
Nobody cried in my class. It didn't have to be in Johnston's class.
Find an algebra.
Quadratic formula. Here's the material Johnson. You'll get over it. It'll be
You find an algebra? Yeah.
Foil.
It was a rough time.
We're gonna have to.
All right.
So I think I was going through some shit.
Oh, yeah. Complex
Oh. Kyle's pissed.
Hey, it wasn't bad.
Hey, we're recording.
I'm just saying.
So, if we distribute, you get 39 over 30x minus 1/3 x to the third plus 1/30th x to the fifth. That's what you get when you multiply through. Just using distributive property.
Where did the 39 over 30?
Well, you
39 times
Oh,
1/30.
that's all together.
Yep, that's all together. So we distribute it. Now, this is one. I'm not making an XY table to do this one because it's going to take me a bunch of points. This is one where using a graphing utility will be beneficial, whether that is Desmos or a graphing calculator.
So you put all that in that one chunk.
All of that into that one chunk.
Okay.
Can you put
X's, you know, that's
Say what?
Can you put extra?
Yeah. All right, so if we're going to graph this, all right, can someone read it to me? Hold on. All right.
It's 39.
Let's go.
Alright, so
39 over 30x minus
You want the foil version?
x.
I don't know. I didn't know.
I don't know the last one.
Hey, I got 1/3 x squared.
No, it's x cubed.
X cubed, sorry.
No, you foiled.
Oh, I just did.
No. No.
Cube.
Oh, the cube.
Three.
Plus 1/30th
X to the fifth.
fifth.
Okay,
Yes.
so if we look, oh, what did I just do?
Yeah,
Okay,
I got that.
here is what the graph looks like. Now, if we just tried to do an XY table, is our graph going to turn out like that? Probably.
Maybe not.
No, because we're going to miss some of the key points, the turn points, stuff like that. Okay? So there are times where graphing utility graphs are good enough. Now, I'm not going to put that type of problem on a test. Period. Just not going to do it.
Hey,
They probably won't do that either, because really at the end of the day, that doesn't do you any good. It just proves can you plug something into a calculator and sketch the graph.
how do you toss together a fraction on one of these?
What is it?
Just divide.
That was the other day.
Was it?
So.
We want beef?
All right, back to it here. Okay, intercepts.
Ah, wait. Oh. How many more?
Not this.
Oh, you use the back of the.
So intercepts. Intercepts are where a point crosses the x or y axis. If it's an x-intercept, you put 0 in for y. To solve for a y-intercept, you put in 0 for x.
It's really weird to have a teacher that teaches. Yeah.
And that's on recording.
It's alright.
To be fair, we gave him a year to frame our declaration of independence, and he never did, so. I don't.
Shout out to Johnson.
All right, we good?
No, no.
Is that 0 or 8?
Yeah.
A0, 0B.
Hey. Oh wait.
Do it.
Good hands.
Is that A0 and then 0B?
Yes.
It's like
Yes, you dropped it. Put your shoes on, you nasty.
He was trying to like.
Dude, do x squared.
Okay, we good now?
Yep.
All right.
Yeah.
Okay, so if we look at, now, you don't have to sketch these, I'm just making sure you understand intercept concepts. So this one, we look, it has 1 y-intercept, it has 0 x-intercepts. Can we agree with that?
Yeah.
It never crosses the x-axis. This one, 3 x-intercepts, 1 y-intercept. This one, 1 x-intercept, 2 y-intercepts. This one has no intercepts at all. Okay? Never crosses the x or the y axis. All of these cases will happen within problems we'll look at this year. Okay? All right, finding intercepts. This should go pretty quick because we talked about this yesterday. To find an x-intercept, you plug in 0 for y and solve for x. To find a y-intercept, you plug 0 in for x and solve for y.
I got it working.
Good?
Yeah.
Alright,
Uh,
last thing for today. Symmetry. Huh?
do we have to try to graph those or sketch those graphs down?
No, you wouldn't have to, no. I just last year had people ask for sketches so they could kind of see what it is.
Okay, but you think it's probably best?
It's up to you. So, symmetry of a graph. You'll have access to this PowerPoint online once we're done. I'll put it up on Schoology. I will.
I
Huh?
don't know how to get on that.
You're not?
No.
Neither am I. I don't know how to get on.
Alright, I'll show
So if you just print off these notes.
I will print them off from now on. I just didn't have time to do that. Okay. From now on, I'll just print them off. So symmetry. There's 3 types of symmetry. Symmetry with the y-axis, which if you think about how you were taught to fold paper in elementary school, that would be hot dog style. Okay? All right? Symmetry with the x-axis, that's hamburger. Okay? Symmetry with the origin is over the line y equals x. So that's if you were able to take something and cut it on the diagonal and it folds perfectly. So a square or something like that. So, yeah, this graph here, and I know the sketch isn't perfect, but it's a semi-solido graph like that to have origin at the origin, or origin symmetry.
We ever
Nah.
come across like equation that we would have to graph like number 3?
We will. Okay, so what I'm going to do is I'm going to save these couple examples for tomorrow right at the start of class. I'm going to give you your first homework assignment, and then I'll show you how to get on school today. Okay. All right. So now this is not due. This homework will be due next Wednesday. But I'm going to strongly suggest that you don't have to do it tonight because I know we have volleyball and everything else tonight. But, okay, you have a 3-day weekend. That'd be a great time to work on this.
When did you say it's due?
This is due next Wednesday. Yep. So, a week from yesterday. So part 1, you should be able to do all of part 1 right now. 1 through 4, 5 through 13 odds, 17 to 22.
This is in the textbook then?
Yep. Wait, hopefully that's the right page. Yes, it is. It is. All right.
Right?
Yep. And part 2, 27 to 35 odds, 39 to 49 odds, 57 to 60. Those are both due on Wednesday of next week. I'm very quickly going to show you Calc Chat.
Is it like a forum for us all to play?
No. All right. So, everybody got that?
No.
I'm going to